Good morning, friends. So, today we will just continue with our second topic. So, in the last lecture, we have finished our first topic, that is the structures of material. Now, this is very interesting topic, that is the mechanical properties and their testing. Why this particular topic is very interesting? Just try to understand, because basically this particular topic is related to the some sort of that mechanical properties and their testing. So whatever the material it is there, we need to find out the basic mechanical properties of that particular material, and those properties are determined by the various methods of the testing. So in this particular chapter, we will cover the tensile test, then the engineering versus true stress strain curve. So in this, we will just see the concept of what is the stress, what is the strain. Already this particular concept you have covered in the engineering mechanics, that is what is the meaning of stress, what is the meaning of strain. Then we will see the types of the stress versus strain curves. So after finishing this particular part, we will just go with the compressive test, bending test, torsion test. So all those tests are very basic tests to determine the properties of material. So after that, we will just go with the hardness test. So there are the three basic types of the hardness test, that is the Brinell, Vickers and Rockwell test. After finishing the hardness test, we will just go with the impact test, fatigue test and grip test. So we will just go with this particular topic. So basically the mechanical properties indicates the response of metal or alloy to elastic and plastic deformation under the applied forces. So we are knowing that in the last topic we have seen what is the elastic deformation and what is the plastic deformation. So basically the mechanical properties indicates the response of metal or alloy to elastic and plastic deformation under the applied forces. So the success of metal forming operations is related to the mechanical properties of the metal being formed, and many finished products are accepted or rejected on the basis of their mechanical properties. So which is very important to understand. So basically any finished product, it is not having the 100% guarantee just to accept it. Might be sometimes this particular product will be gets rejected because it is failed to achieve the required mechanical properties. So according to the conditions, according to its performance, some sort of that mechanical properties which is required, if it is not able to achieve that particular property, might be that particular finished project will be gets rejected. So there are many tests to determine the mechanical properties. When we want to determine the mechanical properties, we need to conduct the many more tests, and those tests are the tensile test, compressive test, bend test, torsion test, impact test or hardness test. So basically the tensile test. So what is the meaning of tensile test? You just try to understand. So tensile test is also called as a tension test, and it is the fundamental material science and engineering test in which a sample is subjected to the controlled tension until the failure. So just to understand this, I will show you the component. So suppose this is the component or specimen. So if we are applying the forces on those particular edges along the axis, it is very important. Along the axis, when we are applying the equal and opposite forces, that particular force is called as a tensile force. So the properties that are directly measured via a tensile test are the ultimate tensile strength, breaking strength. So these are the some sort of that properties that we need to determine through the tensile test. So basically the uniaxial tensile test is most commonly used for obtaining the mechanical characteristic of isotropic material. So how the tensile test it is carried out, we will see via one video. It is there, and in that particular video we can be able to see how that tensile test is carried out. So some materials are also use a biaxial tensile testing. So basically what is the purpose of that tensile test? It is there. So the tensile testing might have a variety of purposes, such as it might be a we are carried out to select a material or items for an application, then predict how the material will perform in use. So for any application, when we want to select a proper material, we need to conduct the tensile test. Then how the material will perform in any conditions, that is the normal or extreme forces that we need to predict, and for that purpose we have to carry out the tensile test, then determine or verify the requirements of the specifications, regulations or contract are met. So whatever may the when any kind of that material, whether it can be able to achieve the requirements, some sort of a specification, either it has to be determined or it has to just verify. So we need to conduct the tensile test, then decide if a new product development program is on track. So again, it is very important if some sort of that sample testing it is needed, just whether we want in the midway of any kind of that product development phase, when we want to check our track whether we are going with the good material selection or not, we have to conduct the tensile test. Then to demonstrate the proof of concept, that is whatever the proofs where some sort of that evidences are needed, whether it is achieving the exact strength or not. For that purpose also we need to conduct the tensile test. So various kind of that reasons are there for to carry out the tensile test. So it is very important which kind of that properties we are going to determine by conducting the tensile strength. So these are the properties that we are going to determine through by conducting the tensile test. So first is the strength. We are just going to check what is the strength of that particular material. Then the ductility. So through the tensile test, we can be able to determine the ductility of any material. Then the elasticity. So again, we can be able to determine the elasticity of the material. So basically we have knows this particular concepts, what is the meaning of ductility, what is the meaning of elasticity, and in the stress strain curve again we will just go in the depth manner with this particular concepts. Then we are just checking the stiffness of that particular material. So ductility in the sense what, how much that particular component can be able to stretch. So when we want to form a thin wire, that material should be a very ductile. So it should not be gets fell easily. So we can be able to pull it, pull it, pull it. So this will be the ductility of the component. So elasticity and stiffness, malleability of that particular component. Then we are just going to determine the modulus of toughness and modulus of resilience. So these are the various properties that we are just determining by conducting the tensile test. So here you just first of all by going with the actual concept or just testing, we need to know what are the various specimens are there. So these are the specimens which is shown. Just we have to manufacture this specimen to carry out the tensile test when we want to know the strength. Likewise, so either that component may be a round shape, either those component might be having a rectangular shape or might be those components are flat shape. So these are the some realistic components which is manufactured just to carry out the tensile test. Now before going for the tensile test, you just understand what is the exactly the nomenclature of those components are required. So basically this particular is the gripping section. So where here we can be able to see for the to conduct the tensile test we need to form some sort of that gripping section. So in this particular specimen, this is the gripping space. So in this particular component, this is the gripping space, and apart from that gripping space, the remaining region is different. So here again this will be a gripping space. This is the gauge length. So here the gauge length, it is shown over here in this particular component. This is the distance between two shoulders, and this is the overall length of the specimen. So basically whatever maybe the forces are there that has been applied on this particular gauge length itself. So this is the diameter of the component for the circular component we are talking about. So just to conduct the tensile test, we need some machine, and that particular machine is called as a universal testing machine. So on UTM, this is very famous word in our mechanical engineering, that is UTM. So the full form of that UTM is the universal testing machine. So you know why it is called as an universal, because universally it is accepted and universally it is the very unique method or universal method to determine the tensile test. There is no any alternative method for this, and that's why this particular machine is called as a universal testing machine. So basically the tensile testing is most often carried out at a material testing laboratory, and according to that whatever the specimen preparation that we have seen over here in this particular slide. So these specimens are manufactured according to the ASTM D638. So D638 is 638, it is the code, and ASTM means American Society for Testing and Measurement. So that is the ASTM. So according to that ASTM, that has been the code, and in that particular code it is given the clear directions how the specimen has to be manufactured, what will be the diameter of that particular specimen, what will be the gauge length of that particular specimen, what should be a overall length of that particular specimen. So everything, it has to be manufactured according to this particular standard. So just try to understand, we cannot be able to manufacture anything. So we need to manufacture these all those dimensions according to this standard only. Whatever may be the standard indicating, according to that only we have to manufacture. That is the among the most common tensile testing protocols. So those protocols we need to follow. The ASTM D638 measures the plastic tensile properties, including the ultimate tensile strength, yield strength, elongation, and position ratio. So basically, when we are manufacturing the specimen according to the standard, it is just determining all those properties. The most common testing machine used in the tensile testing is the universal testing machine. So this is the very most common machine. This type of machine has the two cross head. One is adjusted and for the length of the specimen, and another one is the driven to apply the tension to the test specimen. There are two types: hydraulic powered and electromagnetically powered machines. So the machine must have the proper capability for the test specimen being tested. There are four main parameters, that is the force capacity, speed, precision, and accuracy. So these are the four aspects of the machines. So force capacity refers to the fact that the machine must be able to generate the enough force to fracture the specimen. So whatever the force that machine can be able to develop, that should be enough to fracture the specimen. Then the machine must be able to apply the forces quickly and slowly enough to accurately and precisely to measure the gauge length and those forces has been applied. So this is the diagram of universal testing machine. So this is the realistic machine. In the next slide, we will see the video how exactly the testing has been carried out. So just try to, before going for that, I just want to explain some sort of that nomenclature of that particular machine. So this is the upper head. Here it has been shown, it is called as an upper cross head. So this is the space for the tensile specimen. So here in this real diagram, this will be the space just to mount the tensile test specimen. So this is the movable crosshead, this is the fixed head, and this is the movable crosshead. So this crosshead we can be able to move upward or downward to adjust the length, but this will be a fixed upper head. Then the space for the compressive specimen. So in this portion, we will just conduct the tensile test, and in this particular portion, we can be able to conduct the compression test. So this is the load indicator which is shown over here. This is the speed control knobs. So just to control the speed, those are the knobs are there. Now in this particular slide, we will just go how the tensile testing is carried out. You just see this particular video carefully so you can be able to understand how the tensile test is carried out. So the tensile test one, that is with the yield point phenomena. So this is the UTM. So this is the some sort of that advanced UTM it is there. So before that, this is the real specimen. So in this particular specimen, these are the gripping area. This is the gauge length L0. This is diameter D0 for this particular specimen. So these are the some sort of the dimensions, and this is the actual length. Now in this particular specimen, the upper head is having the movement and lower head it is fixed. So this will be the mounting of that particular specimen in the upper jaw and in the lower jaw. So that specimen now has been fixed. Now we can be able to apply the load. So these are the strain gauges which is applying. So just to calculate how much is the deformation is carried out. So basically just to determine those strains, whatever may be the, now this is the strain gauges that we can be able to determine whatever may be the force has been applied and what will be the deformation. Now in this particular software, we can be able to see how much is the deviation in mm and how much is the force has been applied. Now gradually this force has been increased, which is shown over here. Now here you can be able to see how that forces has been increased. So which is that force has been given in the kilonewton, and position in the sense how the deviation it is there. So this will be the curve formation. So this is on the y-axis, the force F it is there, and on the x-axis the elongation of that particular component, how that elongation is carried out. So that elongation it is very now you can be able to see only 0.2 mm elongation. So in the naked eye we cannot be able to see it, but whatever the strain gauges are there that can be able to determine those elongation. So now the almost 1 mm, near about 2 mm, the deflection will be there, and that curve has been starting forming. Now the force is constant, the force is not building. So the neck formation, next part is the neck formation in that particular specimen will be there. So you can be able to determine that neck formation also. So this now almost the force is constant, but the elongation it is reached up to the near about 9 to 10 mm. That elongation almost it is up now 13 mm elongation. The force is near about the 36 kilonewton, and now there will be the forming of neck has been started. So yield point it is over now, and the neck formation here you can be able to see the neck formation in that particular specimen, and just see how the neck has been formed. Neck in the sense it is like our neck, so it is called as a neck formation. Now it is the point where the specimen will be gets break. So this will be the neck formation. Now this will be the fracture occurs. So this will be the drop point. Here we can be able to see the maximum force. Here it will be reached to the 34, and the deflection So this will be the position, this will be the force or in the elastic phase. So just to calculate that yield force, then this will be a maximum force to achieve the ultimate tensile strength of that particular component. So this will be the stress sigma. Then how to calculate that particular phases that has been shown. Now I think it is very interesting. So these phenomena we have to go with the some sort of that stress strain diagram. So in the next lecture we will just go with that stress strain diagram. So how that exactly the failure is there, it has been shown. So the neck formation in the sense where the fracture will be there at exactly that particular location that neck has been formed. So here you can be able to see how that neck has been formed over here before the fracture. So this will be the neck formation. We can be able to say this is the neck formation. So this is the original component, okay, and this is the broken. So the length you can be able to see over here. So near about this will be the length of the original component, and this will be the this much elongation in that particular component will be takes place. So here whatever may be the diameter, how much that diameter has been reduced. So this will be the original diameter D0, how it has been reduced, it will be shown. Now without any yield, how the specimen will be failed without the yield. So yield position was being shown. Now we can be able to see in this particular without the yield point how the specimen will be gets failed. So if the percentage of carbon is more in that case, so the yield formation will not be takes place. So again we will just go with this particular uh, testing for the second specimen, so you can be able to understand how the without any yield point effect how the failure has been takes place. So now the test has been started. Here you can be able to see the load as well as the position, that is the elongation. So in the previous testing some sort of that yield points was there, but here we cannot be able to observe any kind of that yield point. So almost the 4 to 5 mm deflection is there. Force we need, now we can be able to see almost it is reached up to 43 kilonewton. The deflection, it is near about 9 mm. So in the same component now the neck formation has been started in that particular component. So you can be able to see the neck formation. Oh, so before forming any kind of that neck, suddenly that component will be gets failed. So that much neck formation was not there. So this is the graph of the failure. Again, it is the ductile material, but that yield point was not there, and no any major neck formations was carried out. So after reaching to the certain force limit, immediately that force has been constant and only elongation was takes place. So it will be a 0.2 mm, that is called as an approved stress. So those concepts we will see in the next that lecture, that is in the stress strain curve. Basically just to understand how that tensile test is carried out, we have just seen this particular video. So in that 0.2 mm deflection, that force has been constant over here. So these are the some sort of formulation. So we need this formulation in this next lecture. Here you just understand how that test has been carried out. So thank you very much for the patience listening, and I hope you have understood how the tensile test is carried out. So in the laboratory we will again see how the tensile test is carried out on the realistic component. Now in the next lecture we will just go with the stress strain curves. So thank you very much for the patience listening.